Hello everybody, in today's lecture we are going to discuss error analysis. So error analysis is one of the favorite topics of your competition exams. You'll have many questions from this topic. So I have divided this topic into two. One lecture is this one. So in this lecture we'll be discussing most of the theory and some problems for your practice, okay, and in the next one we are going to dive into whole lot of problems, okay, more and more problems, all from zero level to high level. So today's class is more of theory and some numericals, of course. So the first topic is types of errors. Now this is not that important from competition point of view, so let's just skim through it. So first one is systematic error. So the errors whose sources are known. So source is known. I'm writing it in point form. Source is known and those which can be minimized. So it's systematic errors are errors whose sources are known. You know from where the error is emerging out and you can minimize that. Okay, so under this we have three. First one is experimental. So as the name suggests, it comes through experiments. Like you assume something wrong, so wrong assumptions in experiment. Like in most of the physics problem, like we neglect air resistance, friction. So we are not supposed to do that because in reality the friction and air resistance do exist, right? So wrong assumption in experiment may lead to error. So it leads to error. And how can you minimize that? You don't do any wrong assumption. You account for friction, you account for air resistance, whatever the assumption may be, you account for it. Experimental errors, of course. Then we have instrumental. Again, as the name suggests, it comes from instruments. No, faulty instruments. Okay, you have faulty instruments which measure wrong thing. So yeah, you may that may turn into an error. So how to improve this error? Obviously manufacture good instruments. Okay, so faulty instruments leads to instrumental errors. You're just skimming through the topic, it is not that important. And C is personal. So this is, who is the source for this? You. So it's personal. You are the source. You create problems for yourself. You create the errors. Okay. So it may be due to any reason. We are not that sure about it, but you are the source. You create the errors. So, and what about this? How can it be minimized? So take more and more number of readings. So you count or you measure the thing, whatever your experiment is, more number of times. You repeat the experiment and take the mean values. Okay, so that will reduce personal errors. One classical example, if I had to give you for personal errors, I'd say it as parallax. Okay, so now for 30 seconds you have to mimic me. So what you do, take thumbs up. Okay, now close one of your eyes. I'll go for left eye. Now cover any corner of your room with your thumb. Cover any corner of your room with your thumb. So you covered it. Okay, it seems covered. Now flip your eyes. Close this one, open that one. Close this one, open that one. Okay, did the thumb shift? Yeah, it did. So that is what parallax is. So you'll learn more about it in practicals. Now this thing is not very important, as I said. You can just note down the points. Okay, and one more is that I will mention it. It is random. Okay, it is totally random. It's not D actually, it's 2, since it does not come under systematic errors. Its sources are not known. Random can be through any way. You don't know the sources. It can occur through any random phenomena, maybe due to temperature rise or fall, whatever. So it's completely random, so it will exist. Random errors do exist. So systematic and random. Under systematic we have three. What is systematic? And accordingly resources, and we spoke of the how to minimize, sorry. So you can note this down if you want to, but okay. Now let's speak of something more important. So what was that? First was systematic, second was random. So third is absolute error. So absolute error. Okay, so what is this absolute error? Now I will define it. Difference between true value, TV will say for short form, not television, true value. Difference between true value and measured value taken one at a time. So measured value taken one at a time. One at a time. So you will have some true value. Either they'll provide you the true value in the question, or they will provide you raw data. Like they will do the experiment more and more number of times, and they will provide you numbers like 2.2, 2.3, 2.4. We are taking in general A1, A2. These are like numbers A2, A3, and so on till AN. So they have done the experiment for n times, and they have provided you the raw data. Every time they measure, they report you. Okay, so this is the question actually. Okay, now how to find the true value through raw data? So you take the mean. The simplest thing, you take the mean. Now this true value won't be absolutely the exact true value, it's the so-called true value, because you can't be exact on what you calculate. Okay, you are bound to make errors. To err is to human. Okay, so this value is so-called, let's write it as so-called true value. So but yeah, we have to accept it, so we can assume it as the true value till an and divided by the number of times the experiment is done. So here it's done n times. So true value, you have a formula, quickly note it down. But were we supposed to discuss about true value? No, we wanted to discuss about absolute error. So now let's discuss about that. What does it say? Remove the raw data. It's the difference between true value and measured value. So what were the measured values? They were A1, A2, A3. These are all the measured values, and this is the true value. So what do? It's shown by a sign. So absolute error is shown by a sign delta A. So that is the symbol for, just like TV is for true value, absolute error has delta A. Okay, now it is the difference, which means subtract, you have to subtract true value from measured value. So take one at a time. So one, for A1 it's TV true value minus A1. For A2 it will be, okay, TV minus A2, and this goes on till, it will go on till AN TV minus AN. So you take one at a time, and every time you compute this A1, A2, A3, A4, and go on till you reach the last value. In this case, it's AN. AN. Okay. So if you want to note this down as well, note it down surely. Or you can just note this down as a general formula. So this is what absolute error is. Now we are diving into statistical part, so we need to calculate. Okay, we'll do one example of it later when we discuss more about more errors. So this was a type 3. Quickly note it down, this, and also the definition, what it means. Let's go for type 4 now. which is mean absolute error. Related to mean, yes, it's easy now. You can crack it through words. Just 1 point has to be added. Okay, so mean absolute error, as the name suggests, you should take the mean of absolute errors. What were your absolute errors? If you remember, delta a1 was tv minus a1, a2 was tv minus a2. So this numbers, a1 a2, sorry, a1 a2, all this, an, delta an, so all of these are your your absolute errors, right? They are absolute errors, so you have to take a mean of them, but keep in mind that it should be a modulus. I hope you know what modulus is. So modulus, basically, for those who don't know, is, suppose if you take a positive number and this sign stands for modulus. So this positive number in this sign means it will give the same answer, but if you take a negative number like -2, it will give you 2. So the basic function in physics, we can say, mod function is to convert negative to positive. So it won't affect positive, but it will turn negative to positive. Sounds great. So you have to take the modulus and then the mean, or the mean of modulus, whatever. So it also has a symbol. We'll say it as delta a m. M stands for mean. So delta a mean is, so you take modulus of the first absolute error, second absolute error, third absolute error. Okay, I'll remove this now. I wanted you to revise what absolute error is. So delta e3. Again, you go on till delta an divided by n. So this is what means look like, right? This is so mean, sir. You are so mean. Okay. So this is arithmetic mean. Okay. So you take the mod of each of your absolute errors, which were just calculated a moment before. So absolute errors, and then take the mean. Okay, so this is the formula. If you want to note it down, please make sure you do. Now let's go to the last type, or the second last, maybe. So what was the number? I think it will be 5 now. Yeah, so let's go for relative errors, relative error, and one more which is dependent on it is percentage error. I'll revise all these errors. The ones which were statistics, not those which were not important. I'll revise the ones which are important at the end of this. Okay, I'll just end this now and I'll revise those. Okay, so relative errors are shown as, so you just write relative errors, relative rel dot, and then errors, the symbol for it. If you want to give, you can go ahead and give one of your initials. Okay, so you say it's delta a mean, the ones which we calculated just a moment before, divided by a, or we'll say tb. Okay, so you divide the, what was this? This was mean, mean absolute value, the ones that the one that we discussed before, which was am. If you want to, okay sir, I know delta n upon n, the previous formula. Okay, so this is that. And this tv, the very first thing that we learned is the true value. How do you calculate it? The mean of the raw data. Okay, so if you want to note this down as well, this is the formula for relative error. Now percentage error is not something new, the books will mention it separately, of course, but yeah, you just take the relative error, percentage error equals, you copy paste the same thing and multiply it by 100. That's how fractions are converted into, and you have to write it in terms of percentage. Percentage error is nothing special, but you just take the relative error and multiply it with 100, and then express your answer in terms of percentage. Okay, so lot of theory. No. So we just learned 5 formulas. We'll write them on the next page. You quickly note this down. Pause it. 1, 2, 3. We'll quickly revise the formulas that we learned, and then we'll practice one sort of this example, these types of errors. Okay. First one was true value, which we said we'll take the mean of the raw data A1, A2, A3, all the values that they give us, and divide by the number. Oh, so A3, and divide them by the number of times the number of terms 1, 2, 3. You measure them, you count them. Sorry. Okay. Now what was next? Next was absolute error. So how do you calculate them? So they are many. You calculate one at a time. So delta A1 is TV minus A1. Delta A2 is, you can replace this TV as A also if you find it. Okay. So this is written as TV minus A2. Delta A3 will be, okay sir, I got it, TV minus A3. And in general, if you want to write AN is equal to TV minus AN. Okay, so this is as simple as that. Okay, I have to calculate for each one of them. This was the next thing we learned. Okay, now absolute mean, mean absolute error. Next error was mean absolute error. So you take the mean of this value. Okay, this revision might help you a lot if you didn't pay attention for the last some minutes. So absolute mean error. So you take, am I writing the correct thing? No sir. What is missing? Of course the mod sign is missing. So pay attention that it is the magnitude that matters, the mod sign. Okay, so this is absolute or mean absolute error. So this is true value, absolute error, mean absolute error, and finally we learned percentage or fractional error. So that was given by, you take the mean value delta AM upon A, or the TV upon TV or upon A, whatever you want to write. Fractional error, and finally the percentage error, you multiply this into 100. That is what percentage error is. So this was a quick revision of what we discussed for last 15 minutes maybe. Okay, so let's practice one example so that you are comfortable with this. So they have provided us the data. So they have measured something. They have measured the length of a rod, and they have expressed the data. So 2.1, 2.2. These are like your A1, A2s. 2.3, 2.4, and 2.5. So they have asked for relative error, also for the percentage error, percentage error, and finally they have asked you to express the answer. So one thing which I forgot to mention was how to express your answer. Express the answer in percentage form. So okay, the way you express your answer is, so suppose your answer is A dash whatever, you can give any term. So you write A which is TV plus or minus your error, whatever error they say. Here they have said in percentage form, so you add here, add or subtract percentage error. So this is one more formula, please note it down. Not only percentage error, here there can be any error, either it will be percentage or relative mostly. Okay, so you have to add and subtract that error. So true value, either the error is positive or negative. Okay. Mostly they'll ask for percentage or relative. This is how you express your answer. Note it down. Okay. Now let's try this. So first thing first, relative error, percentage error. But before going for relative error, what was a relative error? Relative error is it's given by delta A mean upon A. So A we can find, this is the true value. We'll take the mean of the raw data. But what about this? So we have to calculate all of the previous things, right? We have to calculate from the very beginning, from true value to absolute error, from absolute error to mean absolute error, and then relative error. Nice question. So let's go for the first one, which is true value, or we'll call it A now. So A1 plus A2, this is A2, this is A3, this is A4, this is A5. So there are 5 terms, 1, 2, 3, 4, 5, and you divide it by 5. Okay, so what will be the mean? So 1, 2, 3, 4, 5. Okay, this is the middlemost number, and they are increasing by 1, 1. So the mean will be 2.3. Yes, you can add and calculate the normal way, or you can do a wise thing is to give 0.1 from here to here. So this becomes 2.3, and 0.2 from 2.5 to here. So this also becomes 2.3. So 2.3, 2.3, 2.3, 2.3, 2.3. Average will be 2.3. This is maths basically. So yeah. So you calculate the true value. Now let's go for the absolute error. So one at a time. Delta A1. So true value, which is 2.3 minus the first value, measured value 2.1. So that gives us 0.2. Delta A2, 2.3 minus 2.1. Sorry, it will be 2.3 minus 2.2. Excuse me. So it will be 0.1. Here A3, here it's 2.3 minus 2.3, 0. A4, 2.3 minus 2.4. So absolute errors can be negative as well. Okay, minus 0.1. And finally we have delta A5. So that's the reason we take the mod. So in order to avoid, we are concerned about the magnitude of error. Okay, so 2.3 minus 2.5, which is minus 0.2. Okay, so remember these values, that delta A1 is this, delta A2 is this. Okay, now because we need to calculate the mean absolute error, we are going to calculate all of those. So delta A mean is represented by that letter. Can I create some more space now? I'll remove this. So we'll note this down somewhere. A is 2.3. So the true value is 2.3. Okay. Where did that go? Anyways, so 3 is to calculate delta A mean. So you take the mod. So 0.2 is positive, no effect on that. 0.1 positive, 0 is also there. Okay, this is also negative. Okay, this is negative, so it will turn into positive. Mod of 0. minus 1 is equal to 0.1. Okay, and A5 minus 0.2, so it will also become positive. Okay. Now count 1, 2, 3, 4, 5. So divided by 5. Okay, now just add 0.2, 0.2, 0.4, 0.5, 0.6. So 0.6 by 5, so that gives us 0.12. Yes. So okay, that is 0.12. So remember significant figures. So you have to remember significant figures. Don't mess up with the rules of significant figures. Now you have to apply the knowledge of significant figures. Those who have not checked the previous lecture, go check it out. YouTube. Yeah, thank you. So yeah, you have to check that out. So count the number of significant figures. Since it's division, here it's 1, here also it's 1. So you have to keep only one significant figure. So 0 point, drop that 2 out. So 0 0.1. 0 0.1 is all what you have. So delta A mean is 0 0.1. Okay, now we won't need this. So finally we have reached the thing where we wanted to, which is calculating the relative error. So relative error will be given by delta A mean upon what? So delta A mean upon A, or the true value. So 0 0.1 upon 2.3. So you have to calculate this. I will directly give you the answer now. NTA will be kind to you, they won't give you such calculation intensive problems. So the answer is 0 0.04378. So okay, forgive me for calculation errors if any. Okay, so now again remember significant figures. You have to remember significant figures for the problems of error. Okay, now here we have one significant figure and here we have two, so we have to round it off to one significant figures. Visit the previous lecture if you are blank now. 0.1 significant figure, so we drop this 8, this becomes 8, we drop that 8 as well, so this becomes 5 followed by an odd number, so this gives us 4. How many do we have? 1, 2. Two significant figures, but we want just one, so drop this as well. Okay, so 0.04 is your answer. Okay, you need to know rounding off as well, which is done in the previous lecture. So my recommendation to you is to watch the previous lecture. Okay, we found the relative error, percentage error, very easy peasy. Error, just multiply this by 100. So shift two decimals, right? When you multiply by 100, so 1, 2, so that gives you 4%. Okay, so percentage error also we calculated. Finally is to express the answer. So let's express the answer now. In percentage form they want. So as I said, how to express that, delta A dash is equal to true value, which is A TV, plus the error, plus minus the percentage error or whatever. Here they have said percentage. So A was 2.3 plus minus 4%. So this is how you report your final answer. I hope you got the how to use the errors, statistical errors, all of those 4, which were absolute, mean absolute, relative and percentage. So this is how you do a problem. Remember significant figures. That is the main point over here. Now the next topic is about errors in operation. So we are going to add two numbers with errors. So then we'll see what happens to the errors. We are going to multiply two quantities with errors, what happens to the error, divide two quantities with error, and what happens to the final error. Okay, what is the result of that? So errors in operation, what happens when we add two quantities having errors. So the rule for addition and subtraction is same, or the proof I'll give you, addition and subtraction. Okay, You just have to remember the final result, but I will give you the proof. So x, suppose there is some quantity, it is given as a plus minus b, or either you add two quantities or you subtract two quantities. It means that. Okay, now but we will have some error. There will be some error in a and there will be some error in b. So let's account for that, and final error in x will be x plus minus delta x. That is how we write, remember? Yes, true value plus the whatever the error is. So we have written delta x for that. So a plus error, a plus minus delta a, which is the error in a, and plus minus b plus minus delta b, which is the error in b. Now let's club things together. So a and this b will bring together, so a plus minus b, and we'll take delta a plus minus delta a and plus minus delta b together. So now if you see, it's easy now. Now x was equal to a plus minus b, so you can cancel this out. Yes. Now what you are left with is plus minus delta x is equal to plus minus delta a plus minus delta b. So but let's simplify this. What can we have? What pairs can we have? Either a can be positive, b can be negative, or we can have a negative, b positive, b positive, or we can have both positive, delta a plus delta b, or we can have both negative, delta a minus b minus delta b. But look out, which one do you think has contributed to the maximum error? Look for this. This is some error in A and minus some error in B. This is the error is getting cancelled somewhat. So yeah, this one is not the correct one. Sorry. And here also B minus A. So there is some error in B and also some error in B. A. So there will be some cancellation. So again, this is not. Here if you see delta A plus delta B, right, both the errors are getting added. This is the correct one. That is also not the correct one. Subtraction. Okay, so you have to account only for this. These are not contributing that much, though they are, but not that much. Okay, so what is the final way of saying that? So the error in x, so you have to say this thing. So the error in x is this way, or you can always say it as x plus delta x is a plus minus b, or then delta a plus delta b. So whenever you add or subtract two errors, I'm making the statement now. Whenever you add or subtract two errors, whenever you add or subtract two quantities, the errors in them are always added. Whenever you add or subtract two quantities, the errors in them are always added. Errors are always added. I've taken the, yes, we took this term. Okay, so this is the final one if you want, or you can remember the statement, which makes it more easier. Whenever we add or subtract two terms, the errors are always added. Okay, let us remove this now. Let's practice one example over it, just for practice, since we are not going to dive into big advanced level problems now. Just easy peasy ones. So we measured two lengths. L1 we measured something 100 plus minus 2 centimeters. Okay, we measured something with error, and here also we measured something 200 plus minus 3 centimeters. So you have to tell what L is. L is this thing, but you have to express it in forms of error and use the previous knowledge. Okay, so L is L1 plus L2. So L1 is that thing 100 plus minus 2 centimeter And here also you have plus 200 plus minus 3 centimeter. Okay, so you directly add this and this, right? This and this, directly add their actual values, and whenever you add or subtract two quantities, the errors are always added. So 2 plus 3, 5. So simple. The statement makes it so simple. Okay, you add this and you add this. If it was subtraction, you suppose let's see, okay, how many of you all get tricked up? L2 minus L1. If I ask you for this, what will be your answer? Okay, try it. I'm removing this. You can try that. L2 minus L1. Let's see who is smart enough to get that. So L2 is 200. So 200 plus minus 3 centimeter minus 100 plus minus 2 centimeter. Okay, so 200 minus 100. Okay, that you'll get correct, 100. But what about the errors? 3 minus 2, 1. No, whenever you add or subtract two quantities, errors are always added. Okay, errors are always added. So it's still 5. Yeah, it was 5 in the previous case as well. 3 plus 2 and 300 plus or minus 5. Here it's 100 plus or minus 5. Okay, so remember that in addition or subtraction, errors are always added. Now let's go for multiplication and division. So the second one is multiplication and division. They also have the same rules, but we have to prove it differently for multiplication and division. So let's take x is equal to ab without errors. When you account for errors, it becomes, okay, I won't tell you the answer first. Let's try doing it through errors now. So x plus delta x. So there is some error which we want to find out. So a plus minus delta a, error in a, and let's account for the error in b as well. So this is error in a, this is error in b. Now open the brackets, ab, a delta b. So ab plus minus a delta b. Then you go for plus minus, yeah, what can you go for? B delta a, and finally delta a into delta b. So plus minus delta a into delta b. But look at this, okay, look at this. This is error into error of a into error of b. This will be approximately very small. These are very small values. Errors are usually very small. So this delta a, let's take it as 0.1, and this also will take it as 0.1. So what does it become? 0.01. So now it's getting even shorter. Okay, so these are in practice very small values. So when you multiply two of them, it even gets more small. Okay, so we can neglect that. Okay, so we are neglecting the smallest term, which is this one. So we multiplying two terms which are less than zeros, and we are getting a very small term, so we are neglecting that term. Which one? Delta a into delta b. That term is neglected. So what I want you now to do is take x common from here. So 1 plus x. How can you take x common from here, sir? Divide by x. No. Okay, so doing that, multiply and see, you will reach here. Okay, and take AB from here. AB, here there is A, there is no B, so you divide by B. Here there is B, there is no A, you divide by A. Okay, so x was equals AB, cancel, so you have 1 plus delta x by x equals 1 plus delta, I'll bring that A on in front, delta A by A plus delta B by B. Okay, 1 also cancels. So what are you left with? I am left with delta x by x is equal to delta plus minus delta A by A plus minus delta B by B. And here also you can see all those combinations, and which one will be the most contributing is the plus one, both with the plus sign. So delta A by A plus delta B by B is the most contributing one. So this is the one that we consider. So this is the error that we have in a particular in multiplication and division. Although we didn't prove it for division, we'll prove it in a while. So this is the error that we have. So what does this look like? Does it strike you? If you see, this is relative error in x. Relative error. You can even multiply 100 for all the terms and say it's percentage error. Okay. So this is relative error in x. This is relative error of a. This is true value of a, and this is the mean absolute error. And here also relative error in b. Interesting. Okay. We'll do it for division and we'll practice one example. So you have to remember that whenever you add or divide two physical quantities with errors, you have to add their relative errors. Whenever you multiply or divide two physical quantities with errors, then you have to add their relative errors. Let's go for division now. I'll drink some water first. Let's go for the division proof now. We'll prove that the relative errors should be added. So let's do that. So x is equal to a by b. Now let's account for the errors as well. X plus delta x, total error, and here we have error in a, here we have error in b. So plus minus, of course. And now what can we take common? Here obviously x, and here you take a by b since we want to cancel. Oh, that's the reason, sir. Plus minus delta a by a, and at the bottom we have delta b by b. Okay, so x and ab, since they are equal, cancel out. Okay, and this one you can still write it as this way: 1 plus delta a by a, and you can get that thing on top, 1 plus delta b by b, and raise it to minus 1. You brought it on top and changed the sign. Okay, now there is a rule in binomial that if it's 1 plus x raised to something k, suppose, and you have that this x is very much less than 1, then you can bring that k down. You can write it in this form. So can you see that over here? Delta b is, I said, very small value like 0.1, and you divide it by some true value which is obviously greater than 1, and that will get even smaller. So okay, delta b is true value. So yeah, so you can apply that knowledge here. You can bring that k down there. So let us remove this. So 1 plus delta x by x. Now this is maths, okay, but just we are proving it. 1 minus, this was plus minus, okay, this was plus minus, here also it's plus minus. So when you get that minus 1 over here, signs change, it becomes minus plus. Not to worry. Okay, now we'll keep on doing this. This was the most important step you have to get, since the derivation is not that important. 1 into 1, 1. So 1 into, this gives us delta b by b. This into 1, delta a by a. And this 2. Again, if you see this 2, delta a into delta b. And again, they are divided by something, okay. So delta A into delta B are small. We have already seen that before, so we can neglect that term. So this into this opening will neglect. Okay, now we are here left with 1 plus delta x upon x. 1 cancels with 1. Again we have the same thing, right? Just that the signs are flipped, but we will take the combination and look out for the one that contributes the most. And we know that, what is that? Both with the plus sign will contribute the most. So delta x by x will be plus minus delta a by a plus delta b by b. We will take their combinations like plus delta a by a minus delta b by b plus, so minus delta a by a plus delta b by b. We will see which combination has the greatest value. So, or is it both of them plus? So if you see this one, the last one has both plus, so the errors are adding to maximum extent, so it is giving rise to a maximum error in this case, if with respect to the others. So we account for that only. So isn't it the same thing? So in multiplication and division, whenever you multiply or divide two quantities with errors, you have to add their relative errors. You have to add their relative errors. So let's try an example. So let us try a problem now based on previous knowledge that we have learned. So they have asked for the area of rectangle. They have provided us the length and breadth. The length is 22.4 plus minus 0.2 centimeter. Breadth is 15.8 plus minus 0.2 centimeters. Okay, and area, as we know, is length into breadth. So they have asked us for relative error in A, relative error in area, or you can call it as delta A upon A. So that is the relative error in A. They have also provided some data which might help you during calculations, which is 0.1 upon 11. Okay, I'll write it. 0.893 and 0.1 divided by 7.9. Okay, this is the data that will help us during calculation. So let's do it. It's easy job. So area is length into breadth. So these quantities are multiplied when you want to find the relative error. Only they have asked. So relative errors. So in multiplication, the two quantities in multiplication, their relative errors should be added. So to find the error in area, we have to add the relative error in length. So before that, a plus minus sign, of course, relative error in L, and also the relative error in breadth. So you can see clearly that this is delta L, this is L, this is delta L, this is delta B, this is B. Okay, so this they have asked us for. So let's do that. Delta L, so which is 0.2 divided by L is 22.4 plus 0.2 divided by 15.8, delta B upon B, delta A upon A. Okay, so here you get, I'm cancelling by 2, so 0.2, 0.1 divided by 1 and 2. I'm doing some maths now. 0.1, and here also you'll get 7 and 9. So this data they have provided. So I had picked up a random question, so it got a little bit calculative. So I provided you this data. But what do we have to keep in mind? Significant figures. Okay, so we have one significant, least one is 1, so one significant. So here also we have to keep it in one significant figures. Those who are filling blank, go and check out the previous lecture. Okay, one significant figure. So you drop this 3. Okay, drop this 3. Drop this 9 as well. So this turns into 9, rounding off. So 9 you dropped, add 1 to the previous one. So it gives us 0.009. Okay, fine. And plus 0.1 upon 7.9, this thing. So we have this. So here also there is only one significant figure. Now let us drop that. Since we drop 7, increase this by 1, so this gives us 3. Again drop that 3, so it's less than 5, so no difference, so 0.01. Now this has 1, this has 1. Now let's add them. So what do we get? 0.09009 and 0.01. So that gives us 0.019. But we have to keep in mind then that whenever we add, we have to follow the rules of significant figures. So here we have 2 decimal places and here 3, so 2 we have to keep it to 2 decimal places, so 1 and 2. So drop this 9, so it gives us 0.02, so 0.02. Okay, this is the basic. From here we emphasize on significant figures. Okay, if you have seen the previous lecture, you'll do it very easily. Now also you can multiply this. Okay, what final answer they had asked us for the relative error, which is 0.02. So this is the final answer. Now also you can multiply this into 100, both the sides, and you will get the percentage error. It will be 2%. Okay, so that's easy. Now let us discuss one more type of error in operation. Addition done, subtraction done, multiplication done, division done. One more. What operation? So it's like multiplication and division only, but okay, I'll show you the example. X is equal to, this is a quantity, physical quantity, a raised to m by b raised to n, or mn, or this way we'll use, whatever. Okay, so this type, same like division only, but it has a bit difference in it. Okay, you can note down the final result. I'll write it here. So it says delta x by x is equal to the relative errors, of course, so n into plus minus delta a by a plus m into delta b by b. Please note it down. The derivation is a bit out of reach, but we'll do it. I'll try to explain it, because it includes using logs and differentiation, which you might not know. So I prefer you that you learn this formula. You directly see the power of a comes down and into relative error of a, plus the power of b comes down into relative error of b. Okay, that is the way to learn. So whatever the power, it comes down, note it down, it comes down into relative error of that quantity. Whatever the power comes down into relative error of that quantity. Okay, now we'll prove it. So if you are not convinced with the proof, you already know the result, no need to worry. Okay, so let's take log on both sides. A by b raised to, no, it's n, here it's n. Okay, so now you can split the log. I am using the properties of log. Log of a by log of b is log of a minus log of b. Okay, now we'll use this. Now we can bring that n down. It's also a property of log. If you are not comfortable, just bear with me for some seconds. Okay, I'm giving you the proof. So final step is differentiation, and differentiation is very helpful in errors. We'll discuss it in next class. Okay, so differentiation of ln of x is 1 by x and dx. What is this dx, sir? So basically for now you consider it as change or the error. For you it's error now. Okay, it's delta a, how it was. So okay, so here also we have dA by A, and we are differentiating it. It's differentiation is a whole chapter. You'll have it in maths later. Okay, anyways, we'll also lump some of it before moving to the next lecture. Okay, not next lecture, next lesson. Okay, so here we have got the answer. So delta x by x, since error is always, you can treat this dx as delta x. Okay, so delta x by x, so we got the answer if you can see that. So error is always plus and minus, it's a range. Okay, now d, I said you can replace it by del, so delta a by a plus m plus or minus, this was minus. Okay, so yeah, this was minus, but here we use plus and minus. Okay, I'm not going to put this bracket now for now. Okay, I'll put by delta b by b. So I need to do one more step before we can conclude the answer, delta a by a, and here you multiply this sign in, so it becomes minus plus. Doesn't really matter. Okay, now what will you do? Look for the combinations, and you already know which one will contribute the most. The one with both sign positive, which is n times delta a by a plus m times delta b by b. So this is the most contributing one, so we'll only account for that. So finally what you have is the formula that I had asked you to remember, which is delta a by a plus m times delta b by b. Basically, power times the relative error of that quantity, power times the relative error of that quantity. That is the way to remember. Okay, so we'll practice one problem on it. You can note down the derivation as well. If you didn't understand, no issues, you know the formula finally. That is what more you that is what is more important. Okay, what can be the example of this? Okay, so let's take an example for this. T is equal to 2 pi under root L by G, time period of pendulum. Okay, so they have said L has an error of 1% and G has an error of 2%. Calculate the error in T. So those were relative errors. If you multiply 100, of course it turns into percentage error. So relative and percentage are closely linked. You can always interconvert them. Okay, so let's do this. So you have to find the error in T. So how to do that? So if you know the formula directly, you can use 2 pi is a constant. Constant won't change. So constant does not have an error. Okay, constants we know for sure. Raised to this is root. I've already told you that root of something is raised to half. So L is raised to half, G is raised to half. So can you see it? Now I am writing it in forms of error. So error in T is error in L. Okay, I won't write this. So since I am writing for error, I have dropped that 2 pi. So this is not actually correct, but okay. I'm using the logic. So now let's go for the relative error in T. Relative error in T, by the formula we know that it's half into delta L by L plus, obviously errors are plus and minus, and half into delta G by G. Now multiply 100 throughout, since we know the percentage and we want it in terms of percentage. So this becomes a percentage error in t, percentage error in t, I'll say. Now this is half, and when you multiply this by 100, it's 1%, so 1%. And here also you'll have g, we have 2%. This 2 and 2 cancel, you get 1. Okay, so what is this? This is half plus 1, so half plus 1, which is 3 by 2. 3 by 2% or 1.5% error is there in t. Okay, yeah, it is correct, I verified it. So the error in t is 1.5. so delta t by t into 100%, we'll say, is this 1.5. Okay, so that was the question about. We will practice higher level examples in the next class, because this error analysis is not a spoonful topic that I will feed you within a single lecture. Uh, I hope you can get it through the length of the lecture now. So that's all for today's lecture. If you made it this far, like the video and subscribe to my channel. And as usual, keep enjoying physics.